If I asked you what the world's biggest problems were, you would probably say something like global warming or the inequality gap, world hunger, lack of housing. But there's way too many problems that we haven't solved. And it's all because we don't have enough people working on important problems. But why? One main reason is people don't have the information needed to actually tackle these problems. But when you look at something like YouTube that has a bunch of videos on things like machine learning, quantum computing, blockchain, all the information is there. And you're also targeting 1.9 billion people all around the world. But the thing is, YouTube isn't set up for success like that.
If I went on an uninfluenced YouTube site, it would have a bunch of unproductive videos that are completely useless. But they help make the user stay on the website for a longer time. But that's not what we need.
So we know YouTube has the possibility to give people the information they need. But the way they're set up is to make ad revenue and keep you on the site longer, not to inform you about things. So how can we tackle this problem and filter out the unproductive videos and instead recommend more productive videos? We can't just tell humans to be more productive because we're naturally lazy. I mean, people are getting paid a bunch of money just to keep us on the site for longer. So I think the best approach we have is NLP, or natural language processing, which is a subfield of artificial intelligence. Natural language processing essentially tries to take data that we have in text or speech form and draw conclusions from that data. But the truth is, computers aren't really good at understanding text or speech. A lot of AI is based around data that includes numbers, for example, image recognition. But the truth is, we have so much data in text and speech form, it's crazy. But we're not able to leverage this yet. And that's what kickstarted the field of natural language processing. And now you got things like Siri, which still isn't the best. Siri, what is Pizza's phone number?
I found 15 places named Pizza. Tap the one you are looking for.
No, I asked for a number. The thing is though, things like question answering and text summarizations are still being updated. But we have cleared up things like spam detection, which we almost have a 99.9% accuracy on. But to tackle this YouTube problem, I'm going to be using something similar to sentiment analysis, which is essentially taking something like a post and predicting if it's good or bad, positive or negative. But instead, we're going to take a YouTube title and see if it's productive or unproductive. The cool thing about this is nobody's ever done something like this with YouTube, which also means I had to create my own data set. The next step was pre-processing.
So for an example of pre-processing, let's see what you would type in a Google search compared to someone like your grandma. If you were trying to find out the winner of AGT, your grandma would probably type something like, who was the winner of America's Got Talent 2019 with the question mark. But you may just say AGT 2019 won or AGT 2019 winner. The point is the sentences are cut short. But why? So this exactly resembles the steps of pre-processing. The first step is tokenization, where you split all the words into individual words separated by quotations. And the computer can recognize this because it will just split words into quotations if they have a space between them. So this will do things for things like question marks, punctuation as well as sometimes things like apostrophe S's. The second step is removing the punctuation and uppercases because a lot of the time it's not that necessary and we want all our data to be similar and our model not to find relations given on unimportant things like uppercases. The third step is removing common stop words. So these are like filler words of, and, the, A lot of the time the computer doesn't need to know this. And we don't use it either. That's one of the main differences between what your grandma would type in the search bar and what you would. So now it's actually starting to look like English. To you, at least. Yeah, don't use this in English class. And the final step is lemmatization, where we take words that may be in past, present tense, and we all convert them to the root word. So here we can see a verb like who was converted to who is. Things like got could also be changed to get depending on the sentence. So those are the 4 main steps. So for my model, this is what it looked like in code. I essentially separated all the punctuation, converted it all to lowercase, tokenized all the words because that was one of the most important stuff for me to do. And the only other thing I did was remove common stop words. With the small sample size data set, I didn't bother with things like lemmatization, but still removing the stop words that appeared often. This is all necessary, but the very next step is encoding, which we already know computers plus words equals not good stuff. So this is where we're going to start to incorporate glove and a thing called encoding. This is where we try to map words to numbers, and those numbers will be fed into the model. So glove is essentially made by Stanford and is trained on the entire Wikipedia dataset. And this is important because not only are we representing words as numbers with dimensions, we are also able to understand the sequential order of text. So what would things like dimensions look like? So you could have anywhere from 50 to 100 dimensions, and essentially it will map out how closely related a word is to that dimension. So as you can see here, cat, dog, human. Does a cat have 4 feet? Depending on that, it may be closer to 1, less than 1. It can be all in between, depending how related it is. And then we can match and find out how closely related words are through something like this graph. And because they're also in number form, we can also perform arithmetic operations like king plus queen minus man is equal to woman. The main point of this is to understand things like order and context, because things like sarcasm are just not great for computers. They essentially need to understand context and sequential order to work, or else things like double negatives wouldn't work as well. So to do this, not only did I use glove, but also an LSTM model. So this essentially takes in mind sequential order and will check glove after each word is read and remember that sequential order on a basic scale. And it will pass forward the output of each word to the next layer when it performs the model and like studies on the next word. So this way, the model will not get tricked. So this is essentially what the model looks like in code. I used a embedding layer, which essentially sorts out all the words to the glove vectors. An LSTM layer, which is the main thing that's going on here, and finally a linear layer to come up with the output. So it would have 2 final nodes. Is it likely productive or unproductive? And whichever one has more confidence in, it will have a closer number to 1 or 0. So overall, my model got an accuracy of 82%.
NLP is a huge field for the future. I mean, you had IBM Watson, which was able to beat people on Jeopardy. But question answering is definitely something that needs to improve if we want to get to general AI. And possibly working in things like hospitals or a chatbot. NLP is really the future if we want to have robots and AI interact with humans. And now you can use YouTube to find out about a bunch of all these stuff and hopefully tackle some of the world's hardest problems.